Question number 1. Write the domain and range of the function below using interval or inequality notation. All right, so the domain is where the function begins along the x-axis. All right, so if you remember this, you can draw lines vertically all the way up to the first point. So our first point here is going to be at -4. And if we keep going and drawing lines, we hit a point everywhere along the function. Okay, and we'll keep going all the way up to infinity because that arrow tells me that this is going to keep going on forever. So for domain in inequality notation, we start at 4 and we go up to infinity. All right, with all the x values that lie in between. At 4, we have a closed circle, so less than or equal. And at infinity, it's always going to be open, so just less than. As an inequality notation, we have a bracket at 4, comma, to infinity with parentheses. All right, let me just erase this. For the range, we're going to come from the bottom up, and right away, I'm already hitting points. This line extends way down and to the right, so that means I'm coming from infinity, negative infinity, okay? And if I keep going, I'll eventually stop hitting points after this, after 3. So as an inequality, we come from negative infinity and we go up to 3 with the collection of y values that lie in between. Infinity is never included, but up here we have a peak, which is a set point on the graph, so this value at 3 will be included. As an interval notation, we come from negative infinity and we go up to 3 with open at infinity and closed at 3. Question number 2. Consider the following functions. We have h of x, g of x, and f of x. We have operations involving h of x and g of x. We need to evaluate at 1 for h and at -2 for g. So that means that we're not going to be using f of x. So to get started, why don't we evaluate h of 1 first. Let's call this blue. So h of 1, using the h function, I'll plug in 1 in for x. So we have 2 times the absolute value of 1 minus 5. Okay. And let's try to simplify this a little bit. 1 minus 5 is -4. Okay, and then 2 times the absolute value -4. Let's simplify the absolute value first. The absolute value of -4 is +4. So we can replace this with the +4. Okay, what's happening here outside, because these are next to each other, is multiplication. So we'll end up multiplying at the end. H of 1 is equal to 2 times 4, which is equal to 8. Okay, so later we'll do this operation, but this is equal to 8. And next, g of -2. We have g of -2. And what I'm going to do is plug in parentheses. I have -3, and then a set of parentheses squared. Inside of the set of parentheses is my x, which is the value of -2. And the reason I do this is because I need to take care of the exponents first by following PEMDAS. So -2 squared is the same as -2 times negative 2, which is equal to positive 4. And multiplying negative 3 times 4 is going to give me negative 12. So g of negative 2 is equal to negative 12. Okay? So now I have the operations of 8 plus a negative 12. And if you add these together, you're going to find out that really you have 8 minus 12, which is negative 4. Question number 3. Use the graph to find the associated inputs and or outputs of the function below. If we are given f of negative 1, the negative 1 implies that we're given the x value. So we're looking for the y value, okay, the output. At negative 1, if we go along the x-axis, negative 1 is located here, so we need to find the matching corresponding point on the graph at negative 1. And that's going to be this point here. So that is, the y value is going to be negative 3. Let's go down here. F of 0 at the x equals 0. Right here, we're going to go down, see a matching y value, which is right here. This lies in between negative 3 and negative 4, so I'm going to call it about negative 3.5. So both of these, we were given inputs, we were looking for the outputs. Now we have f of x is equal to 1, which is, we're giving the output this time, and the x, we're looking for the inputs. Okay, so going backwards, we're going to start out on the y-axis, okay, and try to match the y values with the x values. So f of x is equal to 1 lies here, okay, and I have points right there and right here. So anywhere along this horizontal line where the output is equal to 1, looking for the matching x values. So here the matching x value is negative 3, so that's one solution. And the matching x value here is positive 1, all right? And then this last one here for f of x is equal to negative 5. We're given the output, we're looking for the input. So going along the y-axis, negative 5 is right here. All right, the corresponding point on the graph is right there. And the corresponding x value to that point is about in between negative 4 and negative 5. So negative 4.5. Question number 4, solve the absolute value equation. All right, so the first step is to isolate the absolute value. The operations happening outside of the absolute value is this, so we need to undo that first. Plus 1, the inverse operation is going to be minus 1, so do that on both sides. And then we can rewrite this as the absolute value of negative 2x minus 3 is equal to 4 minus 1, 3. Once this is isolated, now I can split this into the positive solution. Let me use different colors instead. So let's call this the positive solution, where we take negative 2, use the inside of the absolute value, x minus 3, and set it equal to the positive, okay, 3. And then the negative solution is negative 2x minus 3 is equal to negative 3. So this accounts for both of my solutions. We have two-step equations, all right? So here we're gonna add 3 on both sides, and we get the negative 2x is equal to 6, and then we'll divide by negative 2. So one of my answers is going to be x equals negative 3. All right, the negative solution, same steps. We're going to add 3 to both sides. And that leaves us with negative 2x is equal to negative 3 plus 3, which is 0. If we divide both sides by negative 2, then my other solution is x equals 0. If you want to express this as a set, then you could say negative 3 comma 0. Question number 5, solve the absolute value equation. We need to undo the operations happening outside to isolate the absolute value. So the operations happening outside are subtraction of 3 and multiplication of negative 4. So we'll begin by adding 3 on both sides. That's going to cancel that out. And that we're left with negative 4 times the absolute value of 2x plus 6. And that is equal to negative 3 plus 3 happens to be 0. So right away, we'll end up with 0 at the end here, so we'll only have one solution. Let's undo this multiplication, right, by dividing by negative 4. But as you can see, 0 over negative 4 will still be equal to 0. So the absolute value of 2x plus 6 is equal to 0, right? We have one solution. So the solution that we have is 2x plus 6 is equal to 0. It's a two-step equation. So let's subtract 6 on both sides. And then we have 2x equals 0 minus 6 is negative 6. Our last step is to divide both sides by 2. So my answer is going to be x equals negative 3. If you want to write it out in a set, then negative 3 is the only solution. Question number 6, graph the absolute value function. So we have f of x is equal to 1 over 3 times x plus 6 minus 5. All right, we need to look for the vertex. That's going to be our starting point. All right, if you see this, we're going to go opposite of 6. So we're going to go to the left, 6, then down 5. So my vertex is going to be at negative 6, negative 5. Okay? Negative 6 and negative 5 is located right there. And I'll just sketch my axis of symmetry through the vertex. All right? I'll also graph the parent function so that I can compare my transformation. So my parent function is just from 0, 0 with a slope of 1 over 1. All right, so that's my parent function. The slope here, a, is going to be 1 over 3. For every 1 that I go down, I'll go over 3, going to the right first. So up 1 and over 3 this way. And you can plot points along the way and then reflect it about the axis of symmetry to this point. So as you can see, here we have a vertical compression. All right. It looks like this with the factor of 1/3. And compared to the parent function, it's compressed vertically and it's at a different location. Question number 7, graph the absolute value function. So here we have f of x equals negative the absolute value of x minus 7. All right, let's add a k here. Since it's missing, we can add 0. All right, we're going to be moving to the right, opposite of this, and we're going to stay at 0. So my vertex is going to be at 7, 0. All right, so let's graph parent function like that with the slope of 1/1. And my vertex is at 7, 0 right there. Let's draw the axis of symmetry through the vertex. All right, and my slope is going to be in front of this absolute value. There's only a negative here. There's nothing here, so I'll just add a 1, right? I only have 1 there. So a is equal to -1/1. So from my vertex point, I'll go down 1 and over 1. To the right, like that. Okay, and then I'll reflect these points across the axis of symmetry. So I have something that looks like this. Okay, and then I'll just add some arrows here, but this is a full transformation for this problem. Question number 8, write an absolute value function that has been transformed in the following ways. So let's go bullet point by bullet point. Translation of down by 7 units. That's going to affect our k value. So k is equal to -7. Translated to the right by 4 units. So opposite of this, going to the right, we have h equals -4. Reflected across the x-axis means that we have a -a, and compressed vertically by a factor of 2/3 means that a is equal to 2/3. Now plugging all of these values into the general form, right, we have a is 2/3, but it's negative, so -2/3 times the absolute value of x minus h. H is -4, so we have x minus 4, and plus k, we have k equals -7. All right, so if you're unsure about this, let's review again. Translated down by 7 units, okay, that's k minus 7. Translated to the right by 4 units. Opposite of this is 4 units to the right. Reflected across the x-axis, we have a negative here. And compressed vertically by a factor of 2/3, a is equal to 2/3. So this is going to be my answer.